A warm welcome to this session on syllogisms. Have you seen statements like some bees are not seas, all donkeys are monkeys, some teenagers are crocodiles, etc. in aptitude tests? Logical questions which contain these kinds of statements are often referred to as syllogism questions. Some people refer to them as deduction questions. A syllogism is a kind of logical argument in which a conclusion is deduced from the given statements or premises. Now you may ask, what are premises? Premises are statements that we assume to be true. All our logical constructs while solving questions will be built on these assumptions. Statements like all donkeys are monkeys, some teenagers are crocodiles, etc. that we saw earlier belong to a kind of syllogism known as categorical syllogism. There are other types of syllogisms or logical constructs like conditional syllogisms, disjunctive syllogisms, etc. However, when we say syllogism, the most commonly meant idea is that of categorical syllogism. We shall restrict this discussion to categorical syllogisms and leave the others for the time being. A categorical syllogism is a kind of syllogism in which we try to deduce relationships between categories or sets based on the given relationships. Recollect that a set is nothing but a group of elements with some common characteristic. Look at the statement, all donkeys are monkeys. Here, donkeys represent a set or a category. Monkeys represent another set or category. The two sets are related. All elements of the set donkeys are said to be part of another set called monkeys. Now, when you look at these kinds of statements, it is important that you don't attribute the real life meaning of the words monkeys or donkeys to the sets. And don't ask the question, how can all donkeys be monkeys? It is just that instead of using boring names like A, B, C, etc. to represent sets, we make it a bit more interesting using the real life nouns like donkeys, monkeys, teenagers, crocodiles, etc. You would have learned the diagrammatic approach to solving syllogism questions. Diagrammatic method will be easy for people who have good imagination capability. For others, it is very time consuming to draw diagrams and check out the various possible scenarios. In this discussion, we shall learn another method of solving syllogism questions, a rule-based method which will help you find the answer very quickly. For that, you should have some more knowledge about the premises and their characteristics. Let us learn that first. A typical syllogism will have three statements, two premises which we assume to be true, and one conclusion that follows from the two premises. Keep in mind that the relationships given in the premises need not necessarily conform to our real world experience. Each of the premises will relate two categories or sets. Between the two premises, we would have a set that is common, which is known as the middle term. Conclusion will mostly be between the non-middle terms. Conclusion between a term and the middle term is also possible, although not very common. Every premise will have a qualifier, a subject, and a predicate. The first category or set is the subject, and the second category or the set is the predicate. Words like all, some, no, none, some are not, etc. that tell us about the relationship between the categories are called qualifiers. In the premise shown in the slide, elephants is the subject as it is the first category and horses is the predicate. All is the qualifier in this statement. Qualifier is the term that tells us the relationship between the two sets, the subject and the predicate. Based on the qualifiers, we can classify the categorical statements into four categories, namely universal affirmative, universal negative, particular affirmative, and particular negative. Qualifiers and the classifications are given in detail in the table. Please refer the table. Based on the classification of statements into four types, namely universal affirmative, universal negative, particular affirmative, and particular negative, there are four different distribution patterns of subject and predicate. Take a few seconds to go through the table given in the slide. I hope you did not understand. Let me elaborate. This concept of distribution of subject and predicate in a categorical statement comes from an elaborate theory of logic, which we shall not spend time on. We shall just use the result of that theory, which says, in a universal affirmative statement, subject is distributed and predicate is not. In a universal negative statement, subject and predicate are both distributed. In a particular affirmative statement, both subject and predicate are not distributed. In a particular negative statement, subject is not distributed, predicate is distributed. Note the tick mark used to indicate that a term is distributed and a cross mark used to indicate that a term is not distributed. It is strongly recommended that you by heart the table given here. If you are a person who does not like to memorize and would like to have a logical prop to remember the distribution pattern, then look at this. A premise is said to distribute a term if it refers to all members of the class designated by the term. I repeat, a premise is said to distribute a term if it refers to all members of the class designated by the term. This can be used to make out the distribution pattern in all cases except the particular negative statement where it is not that straightforward. Let us look at some examples. All flies are crows is a universal affirmative statement because of the qualifier all. As per the distribution pattern for a universal affirmative statement, the subject flies is distributed, indicated by the tick mark, and the predicate crows is not distributed, indicated by the cross mark. If you look at the statement from a different perspective, here we are referring to the entire category of flies, and so that term is distributed. How do you know that we have referred to the entire category of flies? Look at it this way. Do we know a characteristic that is common to all flies? Yes, they are all crows. So, we say that we have referred to the entire category of flies in the statement, and so it is distributed. Are we referring to the entire category of crows here? Do we know a characteristic that is common to all crows? No. We know that some of them are flies, but we do not know about the others. So we have not referred to the entire category of crows, and so the term crows is not distributed. Use this approach just as a mental prop and do not extrapolate it beyond what is mentioned. Look at the statement, no human is God. As per our classification, it is a universal negative statement. As we have seen, in a universal negative statement, both the subject and the predicate are distributed. Let us look at the categories humans and gods in this statement a bit more closely. Do we know a characteristic common to all humans? Yes. None of them are gods. Do we know a characteristic common to all the gods? Yes. None of them are humans. Thus, in this statement, we have referred to the entire category of gods and humans, and so both the terms are distributed as indicated by the tick marks. Consider the particular affirmative statement, some men are mad. Here, we are not referring to the entire category of men. We are only referring to those men who are mad. We do not know any characteristic common to all men. So the subject men is not distributed. We are also not referring to the entire category of mad people. We know that some mad people are men. But do we know what others are? So the term mad is also not distributed. So here both men and mad are not distributed. In a statement like some plates are not steel, which is a particular negative statement, the subject plates is not distributed while the predicate steel is distributed. Here, it is difficult to create a logical connect as seen in the earlier three cases. So just learn by heart that in a particular negative statement, the subject is not distributed and the predicate is distributed. Now that you have understood the classification of premises into four types and seen the distribution patterns of subject and predicate in those four types, you are ready to learn the rule-based approach for solving syllogism questions. Before we go into the rules, let us spend some more time to ensure that you are absolutely clear on the classification of categorical statements and the distribution of the terms in them. This is very much essential to apply the rules. Refer questions Q1 to Q8. Ensure that you work them out on your own before proceeding in the presentation. Let us look at the exercises one by one. Note that the classification of a premise into one of the four categories is based on the qualifier and the distribution pattern is based on the classification. Look at the qualifier. Some are not. This is the typical qualifier for a particular negative statement. It is particular because of the some and negative because of the not. In a particular negative statement, the subject is not distributed and the predicate is distributed. These are indicated by a cross mark and a tick mark as shown in the slide. The qualifier every represents a universal affirmative statement. In a universal affirmative statement, the subject is distributed and the predicate is not. Thus, doctor is distributed while engineer is not. Some politicians are corrupt is a particular affirmative premise. In a particular affirmative premise, both subject and predicate are not distributed. Here again, it is a particular negative premise. The distribution pattern would be subject butterflies not distributed and the predicate honeybees distributed. The statement no ostrich is a kiwi is a universal negative statement, and in a universal negative statement, both subject and predicate are distributed. It is indicated by tick marks above the subject and the predicate. Many is equivalent to some. So the statement is a particular affirmative statement, and so the subject and predicate are not distributed. That is, both terrorists and extremists are not distributed. This is a universal affirmative statement. You would have probably had a thought whether it is a particular affirmative statement or not because of the term Alexander. As mentioned earlier, do not bring our real life knowledge or experience into syllogisms. Do not consider Alexander as the name of a person. Just consider that there is a set whose name is Alexander and another set whose name is King. Thus, Alexander is a king is as good as saying all Alexanders are kings. So it is a universal affirmative statement, and so the distribution pattern is Alexander distributed, king not distributed. The qualifier only is classified as a universal affirmative statement. For a universal affirmative statement, the distribution pattern is that the first term is distributed and the second term is not. However, it is a bit different in the case of statements with qualifier only. Just look at the statement, only policemen are soldiers once again. Does it mean all policemen are soldiers? Or all soldiers are policemen? Which of these two is correct? Only policemen are soldiers means that to be a soldier, one has to be a policeman. Anyone who is not a policeman will not be a soldier. That means that the statement only policemen are soldiers is equivalent to all soldiers are policemen. All soldiers are policemen is universal affirmative statement for sure. And the distribution pattern is soldiers distributed, policemen not distributed. So when you get statements with a qualifier only, first rewrite it into a statement with all as the qualifier and then mark the distribution pattern of the terms. Let us now look at the rules. A typical syllogism will have three statements, two premises which we assume to be true and one conclusion that follows from the two premises. These rules are applicable only in cases where we are trying to make a conclusion between non-middle terms. Please recollect that a middle term is a term occurring in both the premises. There are 8 rules in total, and let us go through them quickly. Rule 1. Every set of two premises should have 3 and only 3 terms, of which one is common, called the middle term between the two premises. These rules are applicable only in such cases. Rule 2. The middle term must be distributed at least in one of the premises. Otherwise, there cannot be a conclusion in the standard form between the non-middle terms. If one of the premises is negative, then the conclusion should also be negative. If one of the premises is particular, then the conclusion should also be particular. If both the premises are negative, no conclusion can be deduced. If both the premises are particular, no conclusion can be deduced. No term can be distributed in the conclusion if it is not distributed in any of the premises. If both the premises are affirmative, then the conclusion would also be affirmative. What we have glanced through are the 8 rules of solving syllogism questions. You will find that they are quite simple and easy to remember once you learn to apply them. We shall look at how to apply them in the next presentation, Syllogisms Part 2. Take a short mental break and refresh yourself before moving on to Syllogisms Part 2 presentation. Thank you.